My name is Rutuja Doifude and I will be explaining role of RSVP, which is Resource Reservation Protocol in QoS. Introduction to RSVP. What is RSVP? RSVP is a Resource Reservation Protocol, is a signaling protocol for reserving network resources. It works at transport layer but does not transport user data. It used in IP networks to reserve bandwidth for time-sensitive applications. Why is RSVP important? It ensures dedicated bandwidth for critical applications, reduces network congestions by pre-allocating resources, works with both unicast and multicast traffic. RSVP and congestion control. How RSVP helps in congestion control. It controls the flow of data by reserving required resources. It reduces congestion in high traffic environments. It ensures priority handling for important data packets. Mechanism used by RSVP for congestion control. It uses admission control, sub-state mechanism, resource pre-allocation. Role of RSVP in QoS. It establishes end-to-end QoS by reserving bandwidth. It works with integrated services for QoS guarantees. It coordinates with differentiated services for scalable traffic management. QoS parameters controlled by RSVP. These are bandwidth allocation. It guarantees specific bandwidth for applications. Latency reduction. It ensures low delay for real-time services. Priority queuing, which it gives a precedence to time-sensitive packets. Comparison of RSVP with other QoS protocols. RSVP versus DEPSER. RSVP provides uh, per flow reservation, while DEPSER provides per class reservation. RSVP versus MPLS. RSVP is soft state, while MPLS uses label switching. How RSVP works. A step-by-step process. Step 1. Path message is sent from sender to receiver to establish a route. Step 2. The receiver responds with a reserve message to confirm resource reservation. Step 3. Routers along with path allot bandwidth as per the reservation request. Step 4. Periodic refresh messages maintain the reservation. Step 5. Tear down. Messages are used to release resources when no longer needed. RSVP and multicast traffic handling. RSVP supports multicast by allowing multiple receivers to receive resources. RSVP message types. Key RSVP messages are path, establishes path for data transmission, reserves the required resources, pather or reserves, error messages for failure, tear down, releases reserved resources when no longer needed. RSVP packet structure. Messages type field defines the type of RSVP message. Flow specification specifies QoS parameters like bandwidth and latency. Filter specification identifies which packet should receive the reserved QoS. Advantages and challenges of RSVP. Benefits of RSVP. It ensures guaranteed QoS for critical applications. It supports both unicast and multicast traffic. Work dynamically and adapting to changing network conditions. It supports dynamic adjustments based on traffic demands. Challenges faced by RSVP. Uh, a high overhead due to periodic refresh messages, scalability issues in large and complex networks. Uh, it does not optimize for highly dynamic topologies like mobile networks, requires extensive configuration and management. Where is RSVP used? It is used in video conferencing or VoIP, ensures low latency and stable bandwidth. Multimedia streaming guarantees smooth playback without buffering. Enterprise networks supports mission critical applications which with dedicated bandwidth. Internet service providers ISPs helps ISPs manage network congestions effectively. Traffic engineering. RSVP used for explicit routing in MPLS networks. The real-world examples of RSVP are Cisco RSVP implementation used in enterprise-grade networking solutions, RSVP in 5G networks, enhancing service quality in next-generation networks. Conclusion: RSVP plays a vital role in network congestion control by pre-allocating bandwidth. It ensures high-quality QoS for real-time applications. While RSVP has scalability challenges, it remains essential for networks requiring guaranteed service levels.